All right, today what we want to do is learn how to solve multi-step equations. We solved single-step equations with addition and subtraction, and we solved single-step equations using multiplication and division. Now things get a little bit more complicated as we do more than one step at a time. So solving multi-step equations. I first need you to recall your order of operations that you learned in middle school. First, on your order of operations is parentheses or grouping symbols. Next is exponents. Next is evaluating multiplication and division. They're equal power, because we've learned, of course, that division is just multiplication by the reciprocal, so it's really the same power. And then the last thing we evaluate is addition and subtraction. They also have the same power, because really subtraction is just addition of the opposite. So this is our order of operations. As we look at solving equations, what we're going to do is reverse the order of operations. It's basically like taking one shell off after another to finally get to the nut, that is, the answer, okay? By doing a sequence of steps in reverse order of operations, we simplify a difficult equation to a simplified equation. So, what we're going to start with is undoing the addition subtraction first. Then we're going to undo the multiplication and division second. And as you get up into higher math, we will undo exponents and parentheses, but save that for later. Let's take a look at the equation 2x plus 1 equals 2x plus 1 equals 9. All right. The first thing we need to undo is that addition of 1 happening to our variable. So to undo the addition of 1, we subtract 1. Where do we subtract 1 from? Both sides. When we subtract 1 from the left side, we're left with just 2x. When we subtract 1 from the right-hand side, we're left with 8. So we've undone that addition of 1. The next step is to undo the multiplication happening to the variable. Right now the x is multiplied by 2, so to undo that multiplication, we do the inverse operation, we divide. And here, because x is multiplied by 2, we divide by 2. What gets divided by 2? Both sides get divided by 2. On the left-hand side, when we take 2x and divide by 2, we get 1x, or just x. On the right-hand side, when we divide by 2, 8 divided by 2 will give us 4. So I want you to think about this. First we took off this shell of the 1. Then we took off the shell of the 2, the multiplication. This is the same equivalent equation, just much more simplified. We've now got at the meat, at the nut, hiding underneath. These are just equivalent equations meaning the same exact thing. That's a whole lot simpler to understand than that first equation was. Let's try another one. Let's say we've got 3x minus 5 equals 13. First thing we need to undo is addition subtraction. What should we be doing here to undo that subtraction of 5? Add 5. So we're going to add 5 to each side. Adding 5 to the left-hand side leaves us with 3x. Adding 5 to the right-hand side leaves us with 18. Now we need to undo the multiplication or division happening to the variable. Here x is multiplied by 3, so our step is to divide by 3. When we divide by 3 on the left-hand side, we get x. When we divide by 3 on the right-hand side, we get 6. And this final equation is equivalent to the first, just after a series of transformations, taking off those various layers, those various operations happening to the variable. Let's say we have x over 4 plus 1 equals 3. First thing we need to undo is that addition of 1. So we're going to subtract 1. Subtracting 1 from both sides leaves us x over 4 equals 2. Next thing, ask yourself, what is happening to the variable? The x here is being divided by 4, so in order to undo that, we need to multiply by 4. We're performing the inverse operation. So we multiply by 4. When we multiply by 4 on the left-hand side, 4 times x over 4, the 4's cancel. 4 times x over 4 just leaves you with 1x or x. When we multiply 4 on the right-hand side, we get 8. I'm showing this step so you understand what happens, but in practice, we skip that step. We're multiplying by 4 to undo that division, and we just generally go to the line x equals 8. Now, time for you to practice. Let's have you solve. X over 3 minus 7 equals 14. And I'll be back in a minute for you. If you're not sure what to do, your first step should be to add 7. Your next step should be to multiply by 3. And it's always a good idea to write your steps out to the side, because there are two errors that you can make. You can make an error in logic, not knowing what to do, or you can be making an error in the actual mechanics and arithmetic of the problem. But by putting the step out to the side, you help yourself, as well as anybody looking at your work, to understand exactly where your errors are, whether it's in the logic or the arithmetic. So it's always a very good idea as you're learning a new concept to put the steps out to the right-hand side. You'll see those are generally in your textbooks as well. Here, when we add 7 to each side, we get x over 3 equals 21. Now, because x is divided by 3, we need to multiply by 3. It's very tempting for students to just kind of put the numbers together in their mind and say, oh, I see a 3 and a 21, the answer must be 7. No, you need to think logically about this. You have to multiply each side by 3. And when you take 21 by 3, you're not going to get 7. 21 times 3 is 63. Always check your answer if you're in doubt. Plugging a 63 back in for x. 63 divided by 3 is 21. 21 minus 7 is 14. 63 is your true solution. If you had tried to put 7 back in for x, you would have had 7/3, an improper fraction. Something, 2 1/3 minus 7, you definitely would not get 14. So an easy way to check is to always substitute your solution back into the original equation. See if you get a true statement or not.